here I have the limit as x approaches 3 of the quantity x squared minus 9 divided by x minus 3. This is not a limit going to infinity, so we're not going to go and divide by x to the first power. What happens if I just try and plug the number in? Well, if I put 3 in here, I get 3 squared minus 9, 3 minus 3, I get 0 over 0. When we get 0 over 0, that's usually a signal that we can do some algebra to reduce this fraction into something that we can take the limit of. In our case, x squared minus 9 is a difference of squares. It factors into x plus 3, x minus 3. Now we can just go ahead and cross out the x minus 3's, and we just need to do the limit as x approaches 3 of x plus 3. That's a nice simple polynomial. It's a linear function. All we have to do is plug the number in. We get 3 plus 3, or 6. The thing I find here, though, is everyone always wants to divide by the highest power in the numerator. Well, remember, it's x is approaching 3, not either plus or minus infinity. So this is one that we have to do something else, either a table, or in our case, because we got 0 over 0, we said, oh, let's go ahead and do some algebra. Now, if you look at the graph of this, you'll see that you get a straight line, but at 3, there's a little open hole here because this was undefined at 3. But notice what happens. As we get closer and closer to 3, from either side, the function gets closer and closer to 6. And so it matches up with the value we just got from algebra. All right, here's another one, and this one looks really nasty because it's got fractions inside of fractions, but the limit as x approaches 0, the numerator is 1 over x plus 3 minus 1 over 3, and the denominator is x. We're going to try and plug in 0, but when we do that on top, I get 1/3 minus 1/3, which is 0. On the bottom, I also get 0. 0 over 0 is usually a signal that we're going to have to do some algebra here. And the algebra that we're going to do is we're going to try and combine these two fractions together on top. X plus 3 and 3 means we need a common denominator of 3 times x plus 3. So I'm going to go ahead and in the denominator here, I'm going to multiply the bottom by 3, which means, of course, I need to do that on the top. And on the second fraction, I'm going to multiply that denominator by x plus 3, which means I have to do the same thing on the top part of it. What I get is 3 over 3 times x plus 3 minus x plus 3 over 3 times x plus 3. Now that I have a common denominator, I can go ahead and combine those together, and I need to be careful that when I combine them, I remember to subtract each one of those terms there. I've left alone the denominator. I'm not messing with that yet here. And when I put the tops together, I get 3 minus x minus 3, which you see right here. And now I can go ahead and cancel out those 3's. That leaves me with minus x on top divided by 3 times the quantity x plus 3. And in the denominator of this big fraction, we have x. Here's where the algebra comes in. When you divide by x, that's like dividing by x over 1. So let's flip and multiply that. So we get the limit as x approaches 0 of minus x over our LCD, 3 times x plus 3. But when I flip the x over 1, it becomes 1 over x. And oh, look at that. Boom, boom. Those cancel out, leaves me with a negative 1 on top. So now we'll take the limit as x approaches 0. We can go ahead and plug 0 into it, and we get negative 1/9. The reason why these types of things work is look at what we're canceling out. We canceled out the x's here, right? And what happens when you put 0 in place of x? 0 over 0. These two pieces are what were causing the fraction to come out as 0 over 0. So when we canceled it out, that changed our function at one single point. It had been undefined at 0. The new fraction has no problem at 0, but it's exactly the same function, so we can just plug in 0 into that new function. If we go ahead and look at this particular graph, as we get closer and closer to 0, what we're seeing is that there's really an open circle right there. And as we get closer and closer to it, we're getting closer and closer to -1/9. The original function had the open circle, but after we've done all the reducing, it's the exact same graph, but now the open circle gets filled in. And when we plug that number in, we get -1/9.